Hello, welcome to my channel. Today I'll try to just to be brief and to straight to the point, but then because you guys are facing your exams right away, um, I would like to answer a few questions that I just got from some of my viewers, and then without wasting time, let's uh, solve the problems that I received. So the topic for today is sets. Um, and then first of all, before we do anything, I just want us to look at some of the formulas. I call them the exclusion and then inclusion formulas. They are very important when you are dealing with sets. Of course, there are a lot of some other formulas that you should know in order to solve sets problem. But for now, these formulas are valid for the problems that I just received now. But I'll also try to discuss with you guys all the other formulas, all necessary information that we need when it comes to set. So today I'll discuss three questions that I get from my viewers. Okay, so here it says let A and B be any set. So prove that if A union B is equals to B, then A is a subset of B. So first of all, before I start, I just want us to look at what it means by something is a subset of something. So when you are saying something is a subset of something, then we mean that particular set or particular portion is taken from a specific a group of elements, or from a larger portion or anything. But let me just try to illustrate what I'm trying to say so that you guys can understand me well. So if you are having a set, let's say this is a set, and then so let's just refer this example to the problem that we are given. So they are saying A union B is equals to B. Then prove that A is a subset of B. So they are trying to say we should prove that A is a portion of B. So it's a smaller portion taken from B, or it's a smaller part taken from the bigger portion B. So they are assuming that this is A taken from B, and then this is B. This whole thing is B. Okay, so how do we then prove this? There are a lot of ways that we can use to prove this, but for now let's look at the exclusion and inclusion formulas to see if it can give us the answer. But there are definitely a lot of some other ways that we can just play around with, and then they can give you answers. And then I would like to give more explanations on set so that you guys can also get what is going on. Okay, so for now let's solve the equation, and then we can do everything together. So from here it says if you are having if someone happened to give you something like A union B, then you can also write it in the form of A or the modulus of A plus modulus of B minus A intersection B. Note that here we have changed the union to intersection. And then of course, if you are given something A in intersection B, then we write A plus B minus A. Now we change it to union because here it was in an intersection. Okay, so why can't we just write this one in the form of the exclusion and inclusion formulas and see what happens? So I'm just going I'll just do this, or just gonna do that. Okay, so they are saying A union B is equals to B. Okay, let's just rewrite that one down here so we can just visualize it simple. And so I always like to rewrite problems so it becomes clear to me. So it's really a good habit if you rewrite problems. So it's saying that one is equals to B now, and then they want us to prove that this is a subset of. If this is so, then it means A is a subset of B. But that's true, because if you are having a portion of something, then let's say we are having a car, and then we are, let's say for instance, having a steering wheel. So we definitely know that a steering wheel is a subset of a car. We cannot call a steering wheel as a car, but we can say it's a part of a car. So here, if we kind of combine the steering wheel with the car, or put back the steering wheel to the car, then we should get a car. That's what they are actually trying to say. So it's like they are saying, if we combine A with B, then it should give us B, which means A is part of B. It is just like someone takes something from you, and then they ask you, what is this, or for who these things belong to. Then that is definitely yours, or that is definitely you. If I take one of your leg, for instance, and put it aside, and then again put it together again with you, or put it back to you again, then what happens? We get you. So this is what they are trying to say. So we now should have to prove that. Okay, so now, since we know that if we are having A union B, we can write it in the form of A, or the modulus of A, plus B minus A intersection B. So then we should just write that and then find out what we get. So we are saying A union B, A union B, it's equals to this. So it's modulus of A plus modulus of B, and then minus, because here it was union, now it will be intersection A, and then there is rules, or there is actually facts why we write this one in this form. I'll try to compile one of the lecture on this thing, so that you guys can see what is actually going on. But for now, let's just solve this one so that everyone can go and have their exams in peace. Okay, so for now, since we are saying A union B is equals to a modulus of A plus modulus of B minus A intersection B, then we can just replace this with this. Then let's just quickly do that. We get A union, no, it's not A union, but this, we are saying this one is now equals to this, so kind of having modulus of A plus modulus of B modulus of B minus A intersection. So we are just copying this here, just writing it in instead of A union B, because we are saying that is the same thing. Modulus of A intersection B. Now we say is equals to, and then we are getting the equal from here, so we are saying this is equals to this, and then so we're just writing B as it is. Okay, so now we are having a method to solve, and then now if we look at this, we can see that if we take this this one to the other side, let me just highlight on it so that you guys can see. If we take this, so if we take this, let me just have a different color there, undo. So if we take this to this side, this will gonna cancel. So this one now equals to something like this, will give us something like this. We are having modulus of A so now we are having modulus of A and then it's minus A intersection B is equals to B minus B. So it's B minus B. Of course this one goes to 0, this one goes to 0, and then we are now having A minus A intersection B. So let's just write that and see. We are now having A minus A intersection B equals 0. So, and then we can just rewrite this one as A is equals to, now taking this minus A intersection B to the other side, here, then that gives us so now the answer will be A intersection B. Then what this mean is A is equals to A intersection B, or is kind of saying A is A is the same thing as A intersection B. So we are this thing is saying what is in B or in A is also in B, or is also a sub part of B, because we are saying the intersection part is what is found in both A and B. So this is pretty simple and straightforward. So this is answer, this is the final answer, and this hence A is equals to A intersection B. Then this means A is a subset of B. So if you are saying A is equals to A intersection B, it means A is the smaller part of B, because A itself is already equals to A intersection B, means A is the smaller part of the bigger portion, which is B. So you can just write this one, since A is equals to A intersection B, A intersection B, then A is a subset of B. A subset of B. That's it. And then of course there's also some other ways that you can use to prove this one using words. So you can just write it in the other form. Let's say, for instance, if you're having A union B is equals to B, then okay, sorry guys, my minutes are up, so until next time I'll give you the other part. Okay, so let me just draw that so that you guys can get the concept. So this is saying A is equals to A intersection B, then it's saying A is a smaller part that appears in the intersection between A and B. So this is what the whole thing is saying, because we are saying the intersection happens between the two sets. So A is equals to the path um, appearing between the two intersections. So in B, of course, B can be in any other large portion. Let's say maybe this is P. You can say this is P. So A is A is something appearing in A. It's a small section, or you can say it's a small part appearing in B. So because the intersection is what is appearing both in A and B. So this is it, and you can actually just throw that one to the lecture, or if you want to convince or you want to show that you know what you're talking about, because what the lecture wants you to show is that you exactly know what you are talking about. Thank you so much, and thanks for watching. So do